Evaluate the risks by determining the severity and likelihood of potential electrical hazards posed by the handyman's work. Consider the safety of your home, family, and property. Communicate your concerns. Politely express your concerns to the handyman, providing specific examples of his subpar work. Explain the electrical code violations and potential safety risks associated with his methods. Request that he improve his work standards or refer you to a qualified electrician. Establish clear boundaries. Inform the handyman that you will not accept any further electrical work that does not meet acceptable safety standards. Set clear expectations for the quality of work you expect. Seek professional help. If the handyman is unwilling or unable to improve his work, consider hiring a licensed electrician to complete the electrical tasks. An electrician will ensure that the work is done safely and in accordance with electrical codes. Consider legal options. As a last resort, you may consider pursuing legal action if the handyman's work jeopardizes the safety of your home or family. Consult an attorney for legal advice before taking any legal steps. Firstly, document the handyman's subpar work with photos or written notes. Secondly, keep records of all communications with the handyman regarding electrical issues. Thirdly, be prepared to provide evidence of the handyman's negligence or refusal to address safety concerns. Fourthly, prioritize the safety of your home and family above all else. It is important to understand the implications of substandard electrical work and the potential dangers it poses. A ground screw is designed to create a secure and reliable connection between a grounding conductor and a metal enclosure, such as an octagonal box. This connection is crucial for safety as it provides a path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock. Simply placing the grounding conductor under a panhead wood screw does not provide a reliable electrical connection. Wood is an insulator, and even if the screw makes contact with the grounding conductor, the connection is likely to be loose and corroded over time, compromising its effectiveness. Tapping tools are used to create threads in metal, allowing screws to be properly tightened. Using a tapping tool to rethread the hole in the octagonal box would have ensured a secure and reliable connection for the ground screw. Anti-short bushings, also known as redheads or insulating bushings, are used to protect conductors from abrasion and damage when they enter or exit metal enclosures such as electrical boxes. These bushings are typically made of plastic or rubber and have a smooth, rounded surface that prevents sharp edges from cutting into the insulation of the wires. When armored cable, such as AC or MC cable, is cut, it can leave sharp edges on the armor. Without an anti-short bushing, these sharp edges can rub against the conductors inside the cable, eventually causing the insulation to wear away and create a short circuit. Electrical tape is not an adequate substitute for an anti-short bushing. While electrical tape can provide some insulation, it is not designed to withstand the constant abrasion and pressure from the sharp edges of the armor. Over time, the tape can unravel or become brittle, leaving the conductors exposed and vulnerable to damage. Replacing the old octagonal box with the 1900 box is a good first step in properly grounding the circuit. 1900 boxes are typically larger and more robust than octagonal boxes, and they have provisions for grounding screws or clips. When installing the 1900 box, make sure to properly bond it to the grounding system by connecting a grounding conductor from the box to the ground screw or clip. Also, use an anti-short bushing where the armored cable enters the box to protect the conductors from abrasion. When evaluating the risks, consider the potential consequences of electrical hazards such as electric shock, fire, and equipment damage. Assess the likelihood of these hazards occurring based on the quality of the handyman's work and the condition of the existing electrical system. If you are unsure about the risks, consult with a qualified electrician. When communicating your concerns, be polite but firm. Explain to the handyman that you are not comfortable with his methods and that you expect him to adhere to acceptable safety standards. Provide specific examples of his subpar work and explain the potential risks associated with his methods. For example, you could say, "I'm concerned about the way you splice that circuit in the octagonal box." Simply putting the ground wire under a wood screw is not a safe or reliable way to ground the circuit. It's important to use a proper ground screw and ensure that the connection is secure. When establishing clear boundaries, make it clear to the handyman that you will not accept any further electrical work that does not meet acceptable safety standards. Set clear expectations for the quality of work you expect and let him know that you will be inspecting his work to ensure that it meets those standards. If the handyman is unwilling or unable to improve his work, it is important to seek professional help. Hire a licensed electrician to complete the electrical tasks and ensure that the work is done safely and in accordance with electrical codes. A licensed electrician has the training, experience, and tools necessary to perform electrical work safely and correctly. They will also be familiar with local electrical codes and regulations. As a last resort, you may consider pursuing legal action if the handyman's work jeopardizes the safety of your home or family. Consult an attorney for legal advice before taking any legal steps. Documenting the handyman's subbar work is essential. Take photos or videos of his work and keep written notes of any conversations you have with him regarding electrical issues. This documentation can be used as evidence if you need to file a complaint with the licensing board or pursue legal action. Keep records of all communications with the handyman regarding electrical issues. This includes emails, text messages, and phone calls. Be prepared to provide evidence of the handyman's negligence or refusal to address safety concerns. This evidence may include photos, videos, written notes, and communications records. Above all else, prioritize the safety of your home and family. If you are concerned about the safety of the electrical system, do not hesitate to seek professional help. A qualified electrician can inspect the system and make any necessary repairs or upgrades to ensure that it is safe. It is important to remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable performing electrical work yourself, hire a licensed electrician to do it for you. Here are some additional considerations for specific scenarios. In an old ungrounded octagonal box, the lack of a proper grounding system poses a significant risk of electric shock. Replacing the box with a 1900 box and properly grounding it is a crucial step in improving safety. Ensure that the grounding conductor is connected to a grounding electrode system such as a ground rod or a metal water pipe to provide a low impedance path for fault current to return to the source. When using armored cable, always use anti-short bushings to protect the conductors from abrasion. Make sure that the bushings are properly installed and that they fit snugly around the conductors. Never use electrical tape as a substitute for anti-short bushings. Electrical tape is not designed to withstand the constant abrasion and pressure from the sharp edges of the armor, and it can unravel or become brittle over time, leaving the conductors exposed and vulnerable to damage. If you are unsure about any aspect of electrical work, consult with a qualified electrician. They can provide expert advice and guidance to ensure that the work is done safely and correctly. Always follow local electrical codes and regulations. These codes are designed to protect people and property from electrical hazards. Before starting any electrical work, disconnect the power to the circuit at the main service panel. This will help to prevent electric shock. Use insulated tools when working on electrical circuits. This will help to protect you from electric shock. Wear safety glasses to protect your eyes from flying debris. Work in a well-lit area so that you can see what you are doing. If you are working on a ladder, make sure that it is stable and secure. Do not work on electrical circuits when you are wet or standing in water. Avoid loose clothing or jewelry that could get caught in electrical equipment. If you are working on a project that requires a permit, obtain the permit before starting work. Call 811 before you dig to avoid damaging underground utilities. Respect electricity. Electricity can be dangerous if it is not handled properly. By following these safety tips, you can help to prevent electrical accidents and injuries. Remember, when dealing with electrical issues, safety should always be the top priority. Taking the necessary precautions and seeking professional help when needed can protect your home, family, and property from potential electrical hazards. The National Electrical Code or NEC, is a widely adopted standard for safe electrical installation and is updated every 3 years. Familiarizing yourself with relevant NEC articles can provide further guidance on specific electrical work. For example, NEC Article 250 covers grounding and bonding requirements, while NEC Article 300 addresses wiring methods. NEC Table 310.15b16 provides ampacity ratings for various conductor sizes and insulation types. Understanding these ratings is crucial for selecting the appropriate conductors for a given circuit. For example, a 15-amp circuit typically requires a minimum of 14 American wire gauge copper conductors with appropriate insulation. A 20-amp circuit typically requires a minimum of 12 American wire gauge copper conductors with appropriate insulation. It is important to note that these are minimum requirements, and larger conductors may be necessary in certain situations, such as when the circuit is subject to voltage drop or when the conductors are installed in a hot environment. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. This can be caused by long wire runs or by high current draw. Excessive voltage drop can cause equipment to malfunction or overheat. To minimize voltage drop, use larger conductors or shorten the wire runs. The ampacity of a conductor is the maximum amount of current that it can safely carry. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature. If a conductor is carrying more current than its ampacity rating, it can overheat and cause a fire. To prevent this, use conductors with sufficient ampacity ratings for the circuits they serve. Grounding is the process of connecting electrical equipment to the earth. This provides a low impedance path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock. All metal enclosures that house electrical equipment must be grounded. Bonding is the process of connecting all metal parts of an electrical system together. This creates a low impedance path for fault current to flow, which helps to protect people from electric shock. All metal parts of an electrical system must be bonded together, including metal conduit, metal boxes, and metal equipment enclosures. Overcurrent protection devices such as circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. An overload occurs when a circuit is carrying more current than it is designed to carry. A short circuit occurs when there is a direct connection between two conductors that are at different voltages. Overcurrent protection devices will trip or blow when a circuit is overloaded or short-circuited, which helps to prevent fires and electrical shock. GFCI protection is required in many areas of the home, including bathrooms, kitchens, and outdoor locations. GFCIs work by detecting imbalances in the current flowing through a circuit. If an imbalance is detected, the GFCI will trip, cutting off the power to the circuit and preventing electrical shock. SI protection is designed to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. SIs work by detecting the unique characteristics of arc faults and tripping the circuit breaker to energize the circuit. Surge protection is designed to protect electronic equipment from voltage surges. Voltage surges are sudden spikes in voltage that can damage or destroy electronic equipment. Surge protectors work by diverting excess voltage away from the equipment and safely to ground. Proper wiring methods are essential for electrical safety. All wiring must be installed in accordance with the NEC and local electrical codes. Wires must be properly sized for the circuits they serve and must be protected from physical damage. Wire connections must be made using approved methods and must be properly tightened. Electrical boxes must be properly installed and must be grounded. Conduit must be properly supported and must be grounded.